Welcome back to Orlando Math Learning Academy. We continue our college algebra with the first chapter of the textbook, and in this lecture I'm going to talk about the first section is about linear equation and intercept form of linear equation. So chapter 1. Section 1.1 linear equation. And intercept. Okay. So in intermediate algebra level, you learn how to construct the graph of a line using the table. Okay, so as long as you know the x value and you plug into the equation, right, you can get the y value, and the x and the y value represent a point, right? Because it's called the x component and the y component, and you connect all the points together. You can get a curve, or sometimes you can get a line, depends on what equation you have. So in this section, and in geometry, we also know that as long as we have a 2 point, and you connect 2 points together, you can get a line. So in this lecture, in this chapter, they show you how to get the equation of a line, because the line can be represented by the equation or by the function. It's called a linear equation. So a standard form of linear equation, that's what I'm talking about. Okay, so definition. Standard form of a linear equation is denoted as ax plus by equals c, where a, b, and c cannot be all 0. Because if a, b, and c is 0, then you have 0 equal to 0. Then it's not equation. It's nothing over there. Okay. So as long as you have a line, then that line can be represented by this equation or by this form.
Okay, so for example, if I have a coordinate system like that, and this is y, this is x, and I construct a line like this, then this line can be represented by this equation. Okay, so and you see that the line over here intersect the x-axis and y-axis at 2 points, right? At 2 points over here. So the point over here we call that y-intercept point, and the point over here we call that x-intercept point. The coordinate of this point, is 0, y, and the coordinate of this point, x-intercept, is x0. So if you have a point and it's on the y-axis, then the x component always 0, and if you have a point that lie on the x-axis, then the y components
always 0. That's what I mean. Okay, and this is the origin. So if they give you the equation in this form, you can find the x-intercept and the y-intercept easily by just plug in the x, or x equals 0 or y equals 0. Okay, example, find x-intercept and y-intercept of equation 2x plus 6y equal 12. So because the x-intercept and the y-intercept are points, are 2 points, so it must have the order pair form. Okay, so let's find the x-intercept first. Intercept point, it must have the form like this, with something over here. We're gonna find the x value. So how I'm gonna find the x value? I'm gonna plug in 0 into the equation here. You see, I replace the y with 0 because 0 is in the y position component. Okay, so I'm going to replace the 0 into the y. So I have 2x plus 6 times 0, so replace the y with 0, equal 12. So you're going to have 2x equal 12, x equal 6. Here you go. So the x-intercept point over here we have is 6, 0. And for the y-intercept point, is 0 something, right? So 0 here is in the x component position. It means that whatever you see the x in the standard equation, you replace the x with 0, so become 2 times 0. So you see that I replace the x with 0 plus 6y equal 12. Then this is gone, so you have 6y equal 12, y equal 2. Here you go. So 6, 0 and 0, 2 is the coordinate of x-intercept point and y-intercept point. Okay. Okay. So when you grab a line using the table, okay, you will see that sometimes the line kind of slanted upward and sometimes the line kind of slanted downward. It look like this. Sometimes it goes sometimes you see it go, let me use a different colors. Sometimes it goes like this, and sometimes you see it go like this. Okay, why we have that? It's just because of the one of the very important concept, we call that the slope. So the slope is the rate of change. So this is what I'm gonna talk about next. So the second Roman, slope of linear equation. Okay. So okay, let me draw a line, and I will explain to you what does slope mean. Okay, let's draw the coordinate system, and how about we draw the line like this. Okay, and you see over here, the line over here, we have 2 points. I call the point A and point B. We have the intercept and x-intercept and y-intercept, A and B. And I want to grab another line on the same coordinate system, okay, or I can say that I want to make this line a little bit more stiffer. Okay, same line. Okay, so I'm not gonna draw the second line, just I draw the same line, but just make it a little bit stiffer. So how about something like this? Okay, I call a point over here. A point over here called ABC, and a point over here is D. So you see that how much it's slanted, how much this line, the line AB slanted, depends on how further it goes up from point A to point C. Okay, and how further it goes to the right from point B to point D, right? So if you draw this, if you draw it a kind of even more more stiff, something like this, then you see that A moved to another point further, and B moved to the right also further, right? Okay, so this rate of change, the change over here and the change over here, the change of the of 2 point here and the change of 2 point here, it creates a ratio. We call that the slope. All right, so what is the slope? The slope is defined as the ratio, the slope defined as the ratio of vertical change, you see that, of vertical change, because we change from point A to point C, right? Between the vertical change between 2 points, in this case, in our case, is between A and C, or sometimes this change we call it the rise. Okay, to the horizontal change between 2 points, also you see, between B and D in our case, and this change sometimes we call that the run. Okay, so we denote the slope as M equal the change respect to Y, which is the change of the point of 2 points on the y-axis. We call that delta Y. Okay, over delta x over the change with respect to x-axis. Okay, and this is equal to rise over run. Okay, so the M over here we represent for modulus. Okay, rise over run. So the slope of the linear equation is also called rate of change. M okay, M or the slope is sometimes called the rate of change, because you can see that's what the name says for, right? We can see the change from point A to point C and from point B to point A to make this line stiffer. Okay, so if you want to make it less stiff, is you go down. Instead of going up to point C, you go down to another point For example, over here, if you want to make it less steep, I kind of go downward to a point here, and the B, instead of move it to the right, I move to the left. Okay, then your lines become like this, right? See, it's less steep. Okay. And we also have another formula for the slope. If you have 2 points, if you have the x-intercept point, and you have well, when you have the x-intercept point and the y-intercept point, you can connect those 2 points, and you can find the slope using the tangent, which you already learned. I think, oh, probably you have not learned that, so I don't think I should mention. So if you have 2 points, given 2 points, let's name the point A and x1, y1, and point B I have x2, y2, given 2 points. And as long as you have 2 points, you can have the line, right? You can connect the point to get the line. You can, if you have 2 points, you can find the slope of this line by using the formula y2 minus y1 over x2 minus x1. Okay, so this is another formula. Example. For example, I want to give you point A with coordinate 2, 3, and point B with coordinate is 5, 5, 7. Then I can find the slope of line AB is 7 minus 3, because y2 minus y1 over 5 minus 2. So 7 minus 3 is 4. 5 minus 2 is 3. So the slope over here is 4, 3. So if the line kind of slanted upward from left to right, we have the positive slope. So in this case, we have the positive slope. And if the line slanted downward from left to right, I have a negative slope. So remark. Slope M is positive if the line slant upward from left to right. Okay, and slope is negative if the line slant downward from left to right. Or you can say the slope is positive if the line is increasing from left to right. Okay, so in this case, in the case over here, you see that if you go from left to right, the line is increasing, right? So I have positive slope here. And if I go from left to right here, the line kind of going down, right? So the line is kind of decreasing, so I have a negative slope here. And in this picture, the slope is of course always positive, even though that sometimes it gets steeper, sometimes it become less stiff. So, but the slope is always positive when you move from left to right. And sometimes the slope could be 0 too. So if m equals 0, if the line becomes horizontal. Instead of slanted upward or slanted downward, if it would be like this. So this is your x, this is your y, it's like that. Okay, so the line kind of parallel to the x-axis. Okay, how about if the line is vertical line? What happened to the slope? Then we don't have any slope, no slope. So it'll be like this. You have x here, y here, and the line look like this. It's parallel to the y-axis. So if you have the vertical line that parallel to the y-axis, we don't have any slope. Okay, or the slope is undefined. So the line could be on this side, and the line could be, the vertical line also could be on this side. So we don't have any slope. Okay. Okay, good. Okay, so given a linear equation, the graph of linear equation like this, and they want us to calculate the slope. If we just look at the equation, the graph of the equation, and we see that it's slanted downward, right? And I know right away that the slope will be negative. Okay, the slope will be negative, but how much negative? There are two methods. We can use the slope formula, m equal to y2 minus y1 over x2 minus x1, but we need to get the coordinate of 2 points. So the coordinate of 2 points of the x-intercept point and the y-intercept point. So the y-intercept over here, right here, let's name it point A, and the x-intercept is right here, point B, and the coordinate of point A is 0, 6, right? And the coordinate of point B is 2, 0. So as long as I have the coordinate of x-intercept point and y-intercept point, I can plug in to the equation m equal y2 minus y1 over x2 minus x1. Well, it doesn't have to be the coordinate of the x-intercept and the y-intercept, but in this case, it's very easy for me to get the coordinate of the x-intercept and the y-intercept. You can get the coordinate of the point here and point here also, as long as it's line on the line. But it's very hard to estimate the right value. So I'm just go ahead and use the coordinate of x-intercept and the y-intercept. Okay, so I'm gonna plug into the formula. So 0 minus 6 over 2 minus 0. So the slope is negative 3. You see that? And this is true because you see that this is kind of slanted downward, so the slope is always negative. And the second method we can use to find the slope of the graph is to use rise over run method. Rise over run method, we always start, in order to use rise over run method, we always start from the y-intercept. Remember, we always start from the y-intercept. Okay, so m equal, we start from the y-intercept. Over here the y-intercept is a. Okay, the y-intercept is a. Okay, and I want to get down to the x-intercept. I want to get to the x-intercept, and And as you see that there's only one way, is we need to go down, right? I need to go down. I cannot go up in order to get to the point B. I have to go down. So I go down 6 unit. Okay, I go down 6 unit. Then I move to the right 2 unit. You can see that, right? So when you move down 6 unit, move down, you put negative 6. Okay, move to the right, positive 2. So your answer also negative 3. Okay. So if you move up, you cannot go anywhere. However, if you see another graph of the equation, sometimes you have to go up in order to get the x-intercept, or sometimes yes, you have to sometimes you have to go up to get the x-intercept. Okay, and if you go up, it's positive, but if you move to the left, it's negative. So remember that. Moving down and to the left is negative. Okay, but moving up and to the right, or to the right is positive. So you see it over here. In this case, I'm moving down. I move down. So that's why I have negative 6, because I moved down 6. But I move to the next. I move to the right. That's why I have positive 2. Okay. But sometimes you have to move up to the left. Move up and move to the left. Sorry. Okay. For example, in this case, let's do another example. About like this, maybe 4. 2. Okay. Okay, I also start from the y-intercept, which is point A, and I want to get to the x-intercept, which is point B. You see that I have to move up 4 unit, right, and move to the right 2 unit. So the slope will become, moving up 4 unit, positive 4, because I move up, and move to the right, also positive, right? It's positive 2. So your answer will be positive 2, and it makes sense because the slope is slanted upward, right? The most important thing that you always have to start from the y-intercept. You always start from the y-intercept. You don't start from the origin. You don't start from somewhere in a line. You don't start from the x-intercept. You must start from the y-intercept and apply this concept in order to make the slope right. Okay. Okay. So last time I mentioned that the equation of the line can be in the form called standard form. Is ax plus by equals c. But it also can be in another form. It's called slope-intercept form. Okay. So Roman slope intercept form of linear equation so it's denoted as denoted by y equal mx plus b. So if you see the equation and it has this form, y equal to mx plus b, then you know right away that that equation is the linear equation or the linear function. Okay, so m in this case is the slope. B, usually people call it y-intercept, but remember I already say y-intercept is a point. Okay, so B actually the y component of the y-intercept point. Okay. Example. Make it simple. Y equal to 2x plus 3. So you see over here the slope is 2, right? Because it has this form. So this is linear equation, and the slope is 2. M equal 2, and the y-intercept or the y-intercept form, y-intercept point, it has the form of 0, 3. Okay. No concern so far, right? No question. Okay. So if you have the slope is positive, you know it's slanted up. If you have the slope is negative, you know it's slanted downward, right? But if the slope equals 0, if m equals 0, your equation become what? Your slope intercept form become y equal b. Okay, so y equal b is basically is horizontal line. Okay,
and if we don't have slope, so slope undefined, then we start the then we have the vertical line. Then we start a vertical line equation by x equal a constant. A constant means a number. We have vertical line. Okay. Okay, so let's start graphing 3 cases over here. So our first case is this equation. Let's graph it. Okay, so the slope over here is 2. This y-intercept point is 3. Again, we always start from y-intercept 1, 2, 3. Okay, y-intercept it means it's on the y-axis. And 2 is the same as 2 or 1, right? So 2 is positive, 1 is positive, and if positive, we move up if it's positive. So we move up 2 units, so 1, 2, and over 1 is also positive. Okay, the positive we move to the right 1. Okay, so I have the line like this. Oh, sorry. Again, I start from 3. I move up 2 units because it's positive. Then I move to the right 1 because it's positive. If it's negative 1 over here, then I move to the left. But over here, the denominator over here is 1 is positive, and then I have to move to the right. Okay, that's the first case. Our second case is when the slope, then the slope equals 0. Okay, then the slope equal to 0. In this case, using this equation, when x equals 0 here, so you have y equal 3, right? So 1, 2, 3, and we have the horizontal line. Okay, in this case it's y equal 3. Okay, in the third case we had a vertical one. Vertical one where we have the function is x equals something. Let me see. Using also the same equation here. Oh, I can use another one. I can grab the horizontal vertical line x equal 2, for example. So this is the vertical line. So as long as you see something x equal number, you know that's vertical line. So that's 2. Okay, x equal 2, y. So far you learned the concept of the slope, you learned the concept of x-intercept and the y-intercept. Okay, so next I want to show you how to write a linear equation if you are given some information. Okay. Number 4. How to write a linear equation in slope-intercept form. You know the slope-intercept form is y equal to mx plus b. So in order to write a linear equation in slope-intercept form, you need to know two things. You need to find two things. The first thing you have to find is find the slope. Okay. So you can find the slope using by looking at just the graph if you're given the graph, or you can find the slope using a slope the slope formula if they give it you 2 points. Okay. Second, you have to find the b value. It means to find the y-intercept value. Okay. So as long as you find the slope and you find the b-intercept value, you can plug into the slope-intercept form here, and you can get the linear equation easily. Okay. Example. Write a linear equation in slope-intercept form okay, that goes through two points, and name it point A 1, 2, and point B 5, 4. Okay. So how we will write this linear equation? Okay, just follow the method. Okay, find the slope, and they're giving you 2 points. So I'm gonna use the slope formula: y2 minus y1 over x2 minus x1. y2 with 4 minus 2, 5 minus 1, 2 over 4 is 1/2. So it looked like we already finished half of the process, right? We already know the slope, but we need to find the b value. Okay. So how we find the b value? I'm gonna pick one of them. You can use either of them, either of the point.
to plug into the equation to get b. Alright, in this case I will use point A. Okay, so I plug point A into the equation. Okay, so I replace y with 2. I replace m with 1/2, and I replace x with 1 plus b, because I need to find b. Okay, so I need to solve for b. Subtract both sides by the half, so 2 minus a half, 3/2. So as long as I have the slope and as long as I have the b, then I can write the equation. Then my equation become y equal 1/2 x plus 3/2, and we're done. So all you have to remember is that when they ask you to find the equation of the line, or they ask you to write the equation of the line, you need to find two things. You need to find the m and you need to find the b. Okay, in order to find the m, you can use the slope formula, or sometimes they give you the graph. You can read the slope out of the graph. After you find the slope, you can find the b value by plug in one of the points they given you to the equation to solve for the b value. As long as you know the m value and the b value, then I can write the equation. You see that? Okay. Next, we're gonna practice on some problem together. So this part 5 exercises. For the exercise part, I want to cover some problem on page 15 and page let me see, and page 28, 29, 30, 31 of the textbook. So let's just start it with the first problem. I think I'm going to skip number 1 because number 1 is easy. For number 2 on page 15, they want you to find x-intercept and y-intercept of the standard form of linear equation -4x plus 2y equal -40. So I want to find x-intercept and y-intercept, and so as the concept, as long the x-intercept is the intersection point of the x-axis and the line, right, and the y-intercept is the intersection of the line and the y-axis. So for the x-intercept point, we replace y with 0. Okay, so what we have -4x plus 2 times 0 equal -40. So we solve for x value. So x equal to 10. So the intercept point we have will be 10, 0. Okay. For the y-intercept point, replace
x with 0. So we have negative 4 times 0 plus 2y equal negative 40, and 2y equal negative 40, y equal negative 20. So we will have 0, negative 20. Okay. And I want to remind you one more time that the x-intercept and the y-intercept are the points. Okay, and because of the point, we have to write it in order pair. This is order pair, this is order pair. Okay, for question number 1 to 12 is kind of the same, so you will do the same way as I'm doing here. For 13 and 16 is a calculated part, so I think that I don't have to go through it. Okay. For 17 and 25, they want you to graph it. So I will do problem 17 for you. There's a lot of ways to graph it. There's a lot of ways to graph this. So problem 17. Okay, let me see. Okay, 17. I want to graph 5y plus 120 equal 10x. Okay. Let me fix the light a little bit here. I think it's too bright, so I want to fix that a little bit. Let me see. Okay. So if you look at this question, this equation, you see that it's not in standard form yet. Actually, when you want to graph the linear equation, you don't need to put it in standard form. But I want to put this in standard form so that you guys can see that it's easier for you to find x-intercept and y-intercept. That is one of the way to graph the equation, linear equation. Of course, there's another way we will be learning in section 2, and I believe that I already talked about that, which is we have to find the slope and the y-intercept. But I think for problem 17 on this page, I will find x-intercept and y-intercept, and then we graph the linear equation from there. So first of all, I want to change it into standard form. So I subtract both sides by 5y. So I have this. So after I have this, I find x-intercept and y-intercept. So x-intercept point, I replace y with 0. So we have 10x equal 120, x equal 12. So x-intercept will be 12, 0. For y-intercept, I replace x with 0, so I replace x with 0, so I have equation become 5y equal 120 because I replace the x here with 0. Okay, so y give you negative 24. Okay, and if you watching the video and you see some kind of a careless mistake, just let me know, okay? Because I'm human, of course I have mistake. Okay. So as long as you have x-intercept and y-intercept, you know exactly where the line will cut the x-axis and y-axis. You just go ahead and graph it easily. So y-intercept is 12, 0. Oh, x-intercept is 12, 0. So 12, 0 right here. And 0, negative 24. So negative 24 over here. So it's gonna be look like it's gonna be like this. Okay.
It's gonna be like that. It's gonna be increasing. I can tell over here. It's gonna be increasing, so it means that the slope will be positive. Okay, but this, because in this section we just learned section 1.1 over here, we just learned about x-intercept and y-intercept. So the way we graph the linear equation without knowing the slope is find the x-intercept and y-intercept. So I think this one will be very appropriate in this section. Okay. So from 17 and 25 will be the same, so I will not cover all of them. You can do the same and you can get it. For number 26, 26 is a word problem, a real application of x-intercept and y-intercept. So the problem 26, right here, I want you to read it with me. Barry wishes to open a music store that sells various drum sets, an electric and bass guitar. He received a loan of $24,300 to buy DW and per drum set. The DW drum set will cost him $2,700 per set, and the per drum set and $600 per set. And write equation to describe the number of sets Barry can buy with this loan, using D for number of DW and using P for number of per set. Okay, so how we do this? Well, let's do the quick summary, because most of the students, when you read a lot of word problem, and they kind of very confused because too many words. So I'm going to do a quick summary. So for the DW drum set, it is $2,700 per set. Okay, but for the per drum set, it is $900 per set. And they said they want to use D for this and use UP for per set. And they ask you to write equation to describe the number of sets to buy using his loan. He has loan is $24,300. So if you look at this, you know that one set $2,700. So two set is $2,700 add to another $2,700. And three set we have $2,700 add to another set, $2,700 add to another $2,700. So basically it's 3 times $2,700, right? If you have 3 sets. So if you have D number of DW drum set, you will have $2,700 times D. So the first equation will we have 24, because he has only $24,300. Okay, and you will have, if you buy D number of DW drum set, okay, we will have 2,700 times D, right? And the same way, the same logic, plus $900 times P, and the sum of them is only $24,300, because that's all the total loan he has. Okay, so that is for part A. For part B, of course, part B, and we have to use this equation to solve for part B. The part B is ask you to find if he decided to buy only DW. So if he decided to buy only this, okay, with that amount of loan he has, how many could he buy? If he want to buy this only, it means that he didn't want to buy this. Okay, and when he didn't want to buy this, okay, sorry, I need to turn this off. If he doesn't want to buy the program set, it means that the number of program set will be 0, right? Yeah, because he doesn't want to buy it, so this will be 0, and because if it is 0, then the whole equation becomes 24,300 equal 2,700D, and you can solve for D. Okay, So we will have 243 divided by 27. Let's see. 243 divided by 27, we have only 9. Okay, only 9. So it means that if he used all $24,300 to buy only DW drum set, he can buy 9 of them. Okay, for part C, the same thing. If he want to use $24,300 to buy only per drum set, which is D, there's nothing D over here, how much per drum set could he get? Okay, so we have 243 divided by 9, 27. Okay, so if he used $24,300 to buy only the P, he can buy 27 of them. Alright, so that's all for number 26. And it will be the same. It could be the same for number 27, 28. Let me see. I should do number 28 or not. Kind of the same. It's just translation of the answer. So all the word problem is kind of the same. So you can just go ahead and do in the same, use the same concept. All right. Let's jump to page 20. Page 28. Okay, problem 28, page 28. Okay, on this problem I want to find the slope given 2 points. So let's do number 2 on page 28. The given 2 points, -5, -3, and -5, 20. I want to find the slope of these 2 points. Okay. How we want to find the slope of these 2 points? Okay. Let's see. Okay. We do, of course, we have to use slope formula. Slope formula say what? Modulus m y2 minus y1 over x2 minus x1. So this is x1, this is y1, this is x2, this is y2. So I just plug it in. 20 minus -3, because this is minus already, and include this minus, we have 2 minus, and x2 minus x1 minus -5. So we have what? 20 minus 23 over 0. Oh, what happened? If this is a, we cannot divide by 0, of course, you know that. So no slope. It means that this is the slope of a vertical line. So we don't have slope, no slope. Okay. Okay. So we, of course, from number 1 to number 9, you apply the same method using the slope formula to find the slope given 2 points. Okay. For number 22. Okay, 22 on page 29. Page 29. They want you to find the equation of the line in slope-intercept form. In this form, this is the slope-intercept. And according to my lecture, I say that in order to set up the equation in slope-intercept form, you need to find 2 things. First one, you need to find the m, which is the slope. Then afterward, you have to find the b, the y-intercept value. So that is 2 things we need to do. So as long as we get those two things, then we can get the slope-intercept form of the line easily. Okay, and they're giving you the graph. They're giving you this graph. Okay, they're giving you this, and I see that the b value seem to be 20, very clear right here, right? Because it's y-intercept. B value is a y-intercept value, which is 20. So what we have to do is we need to find the slope. Okay, so in this case, in order to find the slope, there of course there's two ways we can get 2 points, get the coordinate of these 2 points, and using the slope formula to get the slope of to get m. However, we can use rise over run method, and as I say, when you use rise over run method, you always start from the y-intercept. Okay, and in order to get from this is a y-intercept point, and I want to get to this one, of course I have to go up, right? So how many I go up? I go up like this, like this, like this, and I go to the right. Okay, I go to the right. So how many unit I go up? I going up, look like from 20 to 30. I'm going up 30 unit, right? So in this case, the m going up, rise, going up positive 30 unit, going to the right, how many? 10, 20, 30, 40, going to right positive, so the slope will be 3, 4. Okay, you see that? 20 to 50, going up 30, and going to right from 0 to 40, going to the right 40 positive. So the slope will be 3, 4. And the b is 20. The b is 20 because right here. B is the y-intercept value. So as long you see that, as long as I got the m, I got the b, then done. 3, 4x plus 20. Then done. And you got this y-intercept. You got the slope-intercept form of the line equation easily. Okay, so that's all for number 24. You can do number 21 and 23 the same thing. They give you the graph, and you just need to get m and the b value. Okay. For number 26, on page 29, also they given you the equation of the line, and they want you to graph it. Okay, I will graph it. Okay, this is your slope. You identify the slope, identify the y-intercept value, -2 and -4. So I graph it. Slope is -4, right? You always start again. You always start from the y-intercept. This is -4. Okay. The -2 is because -2 over +1, right? Okay. I will use rise over a method. Rise over a -2, it look like you start from the y-intercept. I go down 2 unit because it's negative, so go down 1, 2, become -6, right? Then I go to the right 1 unit. Okay, so 1 down to go to right. So you have this going to the right. So your equation becomes this. Okay, so that's the way you graph. Okay. Of course, you can graph using x-intercept point and y-intercept point. You know, we follow this concept as long as you got x-intercept point and y-intercept point. You connect those 2 points, you can draw the line easily. But rise over a method is always the best one. You know, I love both. Doesn't matter which one works with it, as long as you get it right. Okay. Okay, so the rest of them will be application. If you guys have any question from number 1 to number 43 on page 28, 29, just let me know. I will try to do one of the word problem for you. Let me see which ones I should do here. Okay, how about doing number which one is. How about doing number 44 over here? Let's do number 44. Okay, let's read it together. Let's see if we can do number 44 or not. Cameron is studying to be a nutritionist and is doing this to study to determine how long it would take to burn out the meal eaten at a fast food restaurant. Cameron goes to Burger King and order a Whopper, onion ring, and medium Dr. Pepper. After researching the calorie intake from their website, he realized he's consumed a total of 1,400 calories. Okay, let's make a quick summary. 1,400 calories, 600 from the Whopper, 400 from onion. Okay, number 44. Let's say 44, page 29. Okay, total is 1,400 calories, but 670 from the Whopper. So Whopper offer you 670 calories. 450 is from onion ring. Okay, and 280 from pepper. Dr. Pepper Coke. Okay, so after you summarize information, and I keep reading, and say what? It say that Cameron decided to go bowling, which allow a typical 160 pounds per person to burn 219 calories per hour. The total calorie remaining is Rx, and they give you the function of the calorie remaining right here. And they, for portion, they want to identify and interpret the slope of remaining calorie. Okay, so let's see. They give you the equation is Rx equal 219x plus 1,400. So you see that the y-intercept value is basically the total, the initial calorie you have, and because you burning, you exercise, the number of calories go down, right? You burning the calorie. That's why you have negative slope, because you burning the calorie. So the slope over here is negative 219. It means that for each hour, part A, for each hour, the amount of calorie is decreasing by 219 calorie. Okay, it means each hour you burn 219. I mean, you decrease 290. You decrease by 219 calories. That's what I mean. And for portion B, they ask you to estimate the remaining calorie after 3.5 hours. Okay. So this is the equation of the remaining. So after 3.5 hour, it means R 3.5. You plug it in. 3.5 hour, and you will get the answer. Okay, X represents the hour. And for part C, estimate the number of hours can be below if only 300 calories remain. So if 300 calories remain, the whole thing is 300. Then they ask you how long it takes to remain only 400 calories. So this is a linear equation. You go ahead and subtract 1,400 both sides, and divide by negative 210, and give you the x value, which is going to give you the number of calorie. Okay, I'm going to do over here. So 400 minus 1,400 equal to 19x. So give you 1,000. Give you 219x. So x will be 1,000 divided by 219. Whatever you have here. The x value you have, it represent the number of the amount of time for you to remain 400 calories. 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 4 All right. Okay. So that's all the application is. It's all around that. You can do for number 45 easily because they also give you the equation already. Number 45 to number 49, they all the same. Number 50, they give you the graph equation. In order to get it, you need to get the graph. You need to get the standard form of from the graph. Okay, and again, this kind of look like it's look like this. Look like number 22 right here. So as long as you get the graph, you get as long as you get the equation, you can use the same strategy in number 44 to do the word application. Okay. So that's all for section 1.1 and 1.2. Again, I might have some careless mistake. If you find out any careless mistake, just let me know. And on the next couple of days, I will be covering lecture on page let me see, I probably skip 1.3 because there's nothing. Oh no, we cannot skip one. This is a function. Yeah, I will be covering page 35, section 1.3 of chapter 1, and also I also cover section 1.4 of chapter 1. Okay. If you don't understand any concept or any problem or any part of my lecture, please let me know. You can email me, or you can give me some comment under the YouTube video. I will post it in a couple hours. Then we figure out from there. Okay. Yeah. So hopefully that this my second lecture will help you to succeed in college algebra. If you like the video and you think that my video has really helped you in Valencia College, then just subscribe the video and subscribe my channel, and keep posting comment and give me some idea and how to improve my video. Then I have my motivation to have you to offer you guys more video in the next in the future. Okay. All right, please subscribe the video, and I'll see you next time. Bye bye.